I'm going to show you exactly how I built my own binary AI trading bot using Python and how I confidently jumped off a cliff multiple times before getting anywhere useful. If you don't know what binary trading is, it's super simple. You're predicting if the next candle closes higher or lower. No fancy derivatives, no option chains, just up or down, yes or no. And here's why that's actually interesting mathematically. Binary trading is a classification problem, which means we can frame it as 1 if the next candle closes higher or 0 if it closes lower. For the model, I chose XGBoost, gradient boosted decision trees. You'll find this thing winning Kaggle competitions and running on a 5-year-old laptop equally well. For data, I grabbed the ZLAC Bitcoin historical dataset off of Kaggle. Standard OHLCV stuff. Open, high, low, close, volume, the classics. I put it into pandas, cleaned the missing values, converted timestamps, and aggregated across multiple time frames. Then I built a target variable and got ready to become rich. Spoilers, I did not become rich. First attempt, I threw raw OHLCV data straight into XGBoost. No indicators, no pre-processing wizardry. The results, 50% accuracy, a coin flip, an absolutely mediocre coin flip. And honestly, that's the correct answer. Markets are noisy. Short-term price direction is one of the hardest things to predict on the planet. If raw OHLCV data spat out at 70% accuracy, we'll all be retired on a yacht somewhere. The fact that we're not tells you something. So moving on, I added technical indicators. These are mathematical transformation of price data that are supposed to reveal hidden patterns. I threw in the whole gang: SMA, RSI, ATR, VWAP, MACD, support and resistance levels, 6 features in total. We trained the model and pulled up the results. 56.4% accuracy. Okay, now we're cooking. Small improvement, but improvement. And the feature importance chart was genuinely interesting. Turns out only 4 of my 6 features were doing anything meaningful: RSI, volume, ATR, and MACD. SMA and support and resistance were basically freeloading. So I fired the freeloaders and traded on just the 4 that mattered. 56.5%. Less than 1% gain sounds like nothing, but here's the thing. We're operating at the absolute edge of randomness. Every fraction counts. And more importantly, cutting those redundant features didn't just help marginally, it confirmed that we're actively dragging the model down. I was excited, too excited as it turned out, because the numbers were fake. I had made one of the most classic embarrassing mistakes in machine learning: data leakage. I was calculating indicators using the current candle's closing price. Sounds fine, right? Wrong. In real trading, you don't know the current candle's final close until it's actually closed. So my model was quietly, sneakily peeking into the future. The model wasn't smart, it was cheating. Fix was simple: shift all indicators back by 1 candle. Now the model only sees what would have actually been available at prediction time. After retraining, 54% accuracy. Now that's more honest. Then something clicked, and this one actually changed how I thought about the whole project. Accuracy doesn't matter if the model is biased. Someone in the Discord, shout out to the great Squiggle, he told me focus on not what you win, but on what you lose. So I checked the precision and recall, and what I found was genuinely alarming. Recall on sell signals was at 3%, while recall on buy signals was at 98%. The bot wasn't predicting anything, it was just buying every single damn time. Because the dataset had more bullish candles than bearish ones, the model sniffed out the lazy path and planted a flag on it. Just say buy, accuracy looks fine. This is the machine learning equivalent of a student answering C for every multiple choice question and accidentally passing. Technically functional, completely useless. To fix it, I adjusted the class weights inside XGBoost, essentially telling the model missing a sell signal costs just as much as missing a buy signal. You don't get to play favorites. After rebalancing, buy and sell prediction evened out. Accuracy dropped to 51%, but recall between the two classes actually made sense now. 51% is still flirting with random, but at least the model was thinking instead of just screaming buy into the void. At this point, I had to sit with the uncomfortable truth. OHLCV data plus standard indicators on micro timeframes, it's not enough of an edge. At small intervals, markets are dominated by noise and market makers. Indicators derived from the same price data you're trying to predict might just be circular. You're using the echo to predict the sound. So I started digging deeper, reading more. Someone sent me a GitHub repo by Mayurisarda89 focused on Bitcoin price prediction with the XGBoost. They were doing regression, not classification, so a different problem. But their feature engineering approach was noticeably more thoughtful, better pre-processing, smarter scaling, and more intentional feature construction. As Newton loved to say, if I have seen further, it is by standing on the shoulders of giants. Mayurisarda might be my giant. So here's the honest scoreboard so far. First, we had raw data, which gave us a coin flip. We added indicators, which faked our improvement. We fixed that leakage, and we were back to reality. We fixed our class imbalance, a slightly better model. Finally, we realized we needed better features. That's where we are now. This is still very much a work in progress. If you got suggestions, features you've tried, approaches that worked, mistakes I'm about to make that you can see coming, drop them down in the comments. And if you want live updates on the journey, the wins, the failures, I'll leave the Discord, GitHub, and Patreon all linked in the description. Next episode, I'll try feature engineering, figuring out what actually gives the model real edge. Till next time.